answer to be not very. Just you stop whenever you feel.
So yeah, we'll have a talk on natural language processing, and this will be given by Goutham. Goutham, he is a Ph.D. student in the machine learning lab in our department. So, welcome.
Thanks, Indu. Can you all hear me? Anyone who cannot hear me? Probably if you cannot hear me, you cannot hear my question also. I'm sorry to. But at the last part, can you hear me? Okay, fine. Okay, first of all, sorry and for the surprise, and hope it's a pleasant surprise that your topic got changed for today's session. So, so I'm a member of the machine learning lab here. I work with Professor Chiranjeev Bhattacharya, and you probably have some idea of the professors in the department. And Lavanya also told you something yesterday about machine learning and things like that. So I work with Chiranjeev sir, applying machine learning to text. So that's my main specialty. And so today I'm going to talk about NLP and IR. So that is the commonly used abbreviation. So I think the title needs a little bit of explanation. So from reading the title, what did you get would be the topic of this talk? About two things, NLP and IR, probably, right? So it's not about two things. So actually I'm going to talk about IR and what are the things in NLP which come into play in IR. So it's NLP in the context of IR. But that's a very unwieldy title, so I shortened it to something which, which fit on the web page. So it's also an example, a symptomatic example of the challenges we face in IR. Because if I just give this phrase, people took different meanings, right? Someone thought it's two topics, someone may have thought it's one topic with some interrelation. And if I give a query like this in Google, so now what is Google supposed to return? Should it return documents on two different things or on a single document which has both of them in one, right? Yeah, but for example, if I say, Government of India and Government of US, so maybe I want to know about both. So it's never clear what is the right answer. So information retrieval is basically saying, okay, I have an information need, and from there a jump to something called a query. And a query is something you're all familiar with. I don't think anyone here has not used Google or Bing or whatever your favorite search engine is, right? But there's this gap between information need and the query, which there are all the research going on in the recent years is for bridging this gap. Because from the query onwards, okay, it's like a lot of work has been done, and there's a history of work from last 30 years which has been going on in this. So it's like almost well solved problem. So what we'll be looking today is, so for solving the IR problem, there are many approaches. So for example, you want to know some interesting information or like news or some interesting tidbits. So one place where you get it is your Facebook wall, right? I think a lot of you spend at least 5 minutes, and people like me spend half an hour a day on this Facebook wall at least, right? So now where do they get the information from? They use something like network analysis. Who are your friends? Who are your friends' friends? What did they like? These other kinds of information. So that is also IR, but they use network theory and other approaches, right? So the problem of IR can be attacked from many angles, and in this talk we'll be looking at NLP approaches to IR, right? So what is the things in NLP which can be applicable to IR? Okay, and NLP itself is a very vast area, and there are many things in NLP which we will not at all look into in this talk. We'll mainly look at things which are useful for IR. Okay. So if you have any questions, you can just interrupt me in between. Okay. So just to set the context, NLP is a really vast area, and generally it is applied to any activity which which takes as input human language data, English, Kannada, Hindi, whatever your pick, and does something with it using computing resources. So it need not be restricted to text. So voice, audio, music, image. So you have, it's common nowadays. People still use notice boards in some colleges. They put stuff on a physical notice board, but the students are smart, they take their camera phones and take pictures of whatever they want and go back. You don't need to note down anything. So now the lot of data which is being scanned. So there's a huge heritage project going on in every country where they scan their old text from previous days. They want to convert everything into text. So image recognition, text recognition from images is a huge area. So there are many areas which come under the ambit of natural language processing, and which has, it's an interdisciplinary kind of field. So there are lots of other areas which come in. But what we would want to do is mainly fix on the IR aspect of this. So some examples where NLP would come in the context of IR would be like search, which is something you're all familiar with. I don't know how many of you have iPhones. I don't have one, but I've heard the Siri app on the iPhone is pretty good. It can do some nice nifty things. So there's also a lot of work. For example, Google had you can call and search for things. So you can state your search in words and it will convert in text, find some results and send it back to your phone as an SMS. So there are lots of places where voice, NLP can be used to convert voice to text and do things like that. And so I don't know how many of you have used Google Translate. Anyone has used Google Translate? Okay, everyone, almost. So what did you use it for? Can any of you tell? I mean, I know it's for translating, but why did you need to translate anything?
Use it for fooling people in Facebook.
Many?
Telling something in code words.
Oh, okay. So it was the purpose was not to clarify, but to obfuscate. Okay, that's a novel application. Something to be considered. Okay, so a different example would be like if you really want to know something about what's happening in another country. Right? So for example, there's a border dispute going on between India and China on Arunachal Pradesh. Right? So we have our stated view that okay, Arunachal Pradesh is an integral part of India and we have been there for so many years. But China maybe has a different view of it. What is China's view? We would like to know. But China's view will be written in Chinese, obviously. Right? So how do you even decipher something like that? Instead of taking a course in Chinese, a very simple thing you can do is go to Google Translate, the key in Arunachal Pradesh, you will get the name Arunachal Pradesh in Chinese, and you give a Google query for the Chinese word, you will get some documents which you cannot make head or tail of, right? But again you use Google Translate again, right? And you can get some idea. It's not perfect, but you can get some idea of what are the Chinese saying about Arunachal Pradesh, right? This is an example. Yeah, so just to motivate the application. So here the information need is not very well stated. Okay, we just go with some rough thing and we get some kind of results. Anyway, so just this was your motivation. We'll take one specific example of search to go through a series of increasing complexity of how we can implement the search functionality. And then I'll talk about several applications in IR which use NLP and what kind of things we can do there. So basically what I would like to take away from this talk is, okay, IR is an important problem and NLP is an important problem. There are lots of areas in NLP and IR which can take advantage of computing and computer science, algorithms, machine learning, graph theory and so on. And what can we do? What are the things which people do nowadays and what are the problems which you can try to tackle in the next coming years if you are interested in that. Okay. So let's take, okay, this is like a bird's eye view. We will go through this as we go through the talk. So roughly I have classified it into like three main parts. So one is the core IR problems, which search, question answering and things like that. And there are some more fine-grained tasks. So IR is more like the kind of thing we are talking about here is like at a document level. So at sentence level, if you go, there are more fine-grained tasks like extracting names and places from sentences. So they're harder problems and require more specialized techniques, right? And some other things. We'll go into that as we go further. So we'll take the first example of search. So the basic thing which almost everyone would have done is Control F. Right? I don't think people can live without Control F, at least on a computer. Many times at home I lose my keys and I think of doing Control F. Unfortunately, it's still not possible. But I think you would have heard there's an app called Keys or something like that, which lets you find things. Have you heard of it? Okay, so there is basically some kind of RFID based or some kind of electronic based token which you will have. So you keep it with your keys as a keychain, and in case you lose your key, so everyone who has the app will be connected to the cloud, and that sensor will be sending off signals. So whoever is having that app nearby, whoever's cell phone is having that app, he will pick up that, okay, the key is here, and that will be conveyed to the cloud, and I'll get a kind of coordinates of where my key is. So if I've lost it somewhere. So anyway, so that's an aside. So coming back to the basic question of finding a word in a text document. So any idea how it is implemented in Firefox or Word or Notepad or something like that? How would you go about implementing it? Yeah. So I'm sure you have answers. Do you want me to pick up people and ask, or just to get, because we had a good lunch hopefully, and all the blood would have flowed here. I'm trying to get it back up. Okay, so in basic, simple way of doing it, okay, reading the stream of characters in the file, and supposing I'm looking for a word like exam, then I would have a moving window. I'll scan the whole file, and wherever I find an exam, I'll flag it, and it's okay, I found the word in the file. It's a basic way of doing it. Right? Now supposing my file is big, right? If the file is like the entire contents of a novel or an encyclopedia, and I'm looking for some word in it, right? Then how would I go about doing it? I can still do it the same way, it would still work, but you can imagine how much time it would take, right? So the next immediate approach would be to use a hash table. So it would be you would have to construct a data structure and store it, and whenever you want to search for it in the file, so what would this do basically? You will assign a number for every word, and almost order of one time you can find out whether the word is there in the file or not, right? So now, okay, make it a little more complex. Supposing we are looking for this word in many files, then what would I do? So one way is to construct this hash for each file, right? But maybe we can do better, right? So this is what is typically called an inverted index. Essentially, it's an index. So you would have a similar hash, and this time you will take the words in all the documents, right? And then for each word, you'll have a pointer saying, okay, which document does this occur in, right? So now you can still do it in approximately order of one time. Order of 1 plus the number of documents which you have up to with an appropriate scaling, because of course every word will not occur in every document. So what is the next thing that we can think of, right? Supposing you want to search for 2 words. I mean, typically I don't know, most of you would have used Google queries with at least 2 words in it, right? Very rarely you would use just one word in a query, right? So if you have 2 words, how would you go about doing it? So
we will find a combination like something which contains both the word and the hash thing which contains the first one and
exactly.
Contains
Yeah. So if you are looking for good and example, so if I am looking for good and example, then I would take these file lists F1, F3, F7 and so on. So I think I should use it. So I will take this list and I will just intersect them. Right? So that's a very simplistic solution which you can think of, right? But now supposing I want to look for good example the way I have stated it. I don't want good somewhere and example somewhere in the document. So the current solution will just give you that, right? So if I want a phrase query, right, what would you do? Then so the intersection would do what? So what is this saying? This is saying that this word exists in this document, but it doesn't say where it exists. Right? Similarly for the example, right? But it could exist in the first, the good could be in the first word and example could be the last word, right? But I want the phrase good example. So one solution is to just scan and find it. So I could find this good example here, but that again has its own problems. So yeah, exactly. So that's the thing which the researchers have found out already. So the next thing to do would be to store in the file every position where it occurred in the file. So it occurred, it was the 9th word and the 75th word in the file F1, right? So now I take the lists of good and example, first intersect on the file name and then look at the indexes, the offset into the file. So there's 75 and 76, and so I know that the phrase exists, right? So this would be a way of looking for phrase queries. And in general it's called a proximity query. So if I want to say that, okay, I want to find good within 3 words of example, in nearby example or in the same sentence, then you can use things like this to solve that problem. Right? So have we solved the search problem, more or less? Right? But we see that it's not sufficient because we don't always know the exact word to query. Right? If we have queried for maybe forest and the document contains jungle, we would still want it. Right? So what would you do then? So typically, so this is an example of query expansion where you look for other terms which are probably related to the query that I have, and then expand your query and then try to find all the documents related to any of these words and then do an intersection. That would be an idea, right? Right? But again, we have not still solved the problem because, I mean, at least I make a lot of spelling mistakes when I type, and I think a lot of people do the same, especially when you're in a hurry. So if you're making spelling mistakes, then what do you do? Right? So then you need to have some way of handling that also. I'm sure you would have used Google search engine or Bing. There will be sometimes if you misspell, they will give a suggestion. Okay, did you mean this? Things like that, right? Right. So this is the next problem that we have to face when you are building a search engine. But yeah, it's always also not clear whether it's a spelling mistake or not. If I have said RREST, it could be a spelling mistake of forest, or I could be querying for Forrest Gump, the movie. Have you heard of the movie Forrest Gump? Probably, right? So then it's not even, you're not even sure if it's a spelling mistake or not. So now you see, we have an information need and the manifestation of that as a query. So that huge gap is there, and now the search engine has to guess. It has to jump from there back to your information need. It's a non-trivial job, and yeah, so that's where all the complexity comes in, right? So that's where all these probabilistic models, machine learning, and all those things come into the picture. So in this case, yeah, we may be sure that it's a spelling mistake or not. So typically, when we are uncertain, we use a good way to model the problem is using probabilities. So for example, just to motivate this, so supposing your query is W, right? So W is forest, right? And now A is every word in every document. So you want to see which is the correct word which I mean when I say forest. Do I actually mean with a double R or with a single R? So that's the question, right? So okay, so I'm looking for forest. Sorry, so W is forest. So now A could be either forest or forest with a double R. So by Bayes rule, we can just write it in this way. I think everyone is familiar with Bayes rule, right? I don't need to explain that. So for example, if you look at this term, so what is this saying? P of W given A. So this is the actual word in the document. The A is the actual word, and W is my query. So this is saying what is the probability that I misspell the actual word A by the query word W. So typically this you are most likely to misspell it if it's just one letter away from just an insertion or a deletion of a letter will give you the original word. So that is one way of quantifying this probability, saying that okay, you probably have misspelled it if it's a very minor change, right? Ram and Sita is it's very unlikely to be a misspelling, right? But Ram and Sam, it's probably a misspelling, right? More likely it's a misspelling. So that is this, and P of A is saying that okay, how likely is this to be the actual word, right? So for example, so if W is forest and A is forest, how likely is forest in the set of document itself? If forest is a very rare word, right, then I'll probably go with forest itself. You see the difference? Forest will probably occur more times than this with the double R. This is how I would try to quantify, okay, I am uncertain what is the right spelling, and I'll try to guess now. Based on, okay, what other people have done, what is the statistics in the corpus, and so on. Right? So this is a kind of toy example to illustrate, okay, how would you increase complexity from a simple algorithmic data structures based approach to introduce probabilistic models and higher level models to model more increasing complexity and uncertainty, right? So so just moving slightly further now. So information retrieval as document retrieval is something you're all familiar with, because you've used Google, you give an information need as a query and you get a set of documents which probably contain the answer to your question. What if it's possible to directly answer the question? So that is another problem which people are trying to answer. So the broad area where it comes is question answering. So instead of looking for just browsing a topic and seeing what all information is there, I might be asking specific questions. Like for example, I might say, okay, what is the exchange rate of rupee versus dollar today, right? Or what is the weather in Bangalore today? Things like that, right? So this is the kind of question where if it's possible to give a specific answer, it will be more helpful to the user. So for example, I gave a query, where is Lal Bagh? And if you have time, you should visit, whoever is not from Bangalore. It's a very nice place. So in addition to giving a Wikipedia article and some other articles, documents, Google is also trying to give you the exact answer to your question, right? So how do we reach here from document retrieval to exact answer retrieval, right? So this is a slightly more challenging problem, as you can imagine, right? So how do you go about modeling this? So there are a lot of challenges here. So I mean, to begin with, first you have to identify that it is a question, right? Because I've just given a series of words, you are not even sure. Many times people don't even put a question mark, and if they could put a question mark, they may not mean it. So first of all, you have to identify that it's a question, and then you have to break it. Okay, so you have to say, okay, what is this? What are you looking for? Are you looking for a country? Are you looking for a person? Are you looking for an animal? Are you looking for a landmark? What is Lal Bagh? You're not sure, and you have to consider this as a phrase and not as two different words, right? So this is a really tough problem, and there are approaches which have achieved some success, right? But mostly they are in specific area. So people don't try to make overall a general question answering system. They'll say, okay, I will attack people. So I'll say, okay, if you ask me who is kind of questions, I'll try to give you an answer. So who is this person? Who is that person? Then I will have a set of documents, and from the documents I'll try to find this person, and okay, from the text of the document I'll try to get some kind of summary of description of this person. Or if I'm looking for locations, then I'll try to get coordinates, latitude, longitude, or address, and so on, things like that. So for specific areas, people have tried to find solutions, and so this is much, not yet unsolved, and a lot of open areas are there for research. So if any of you are interested, it's especially interesting because in the Indian context, a lot of information is not available to most people. Right? It's there in some government document somewhere or somewhere on the web, and most people may not have access to the internet, or they won't have the literacy to browse and find the answers on their own. Searching using browsers, using search engines is also a skill. Probably you have grown into it, so it's second nature to you. But I have observed, especially elders trying to find information. We just started using computers and the internet, and they find it really tough. They don't know the idioms which work, what is the right kind of keywords to use. So it's really difficult, and this kind of thing will be really helpful to them. So so this is a rich area for research and finding new things. Anyway, so the most recent thing which has happened, which made a lot of news recently, was IBM Watson. I don't know if you have heard about it. So they built a machine program to participate in a quiz, and it beat the previous winner of the quiz. So with just data from the web and Wikipedia and so on, they built a huge database and a lot of NLP techniques. So the question was not fed into it in some structured form. The question was given to it by a person. So it was a natural language question given, and it passed the question and tried to find answers. So this is really exciting that is happening in the question answering arena in recent times. It happened a couple of years back. So you can look it up and see what's happening on that front. And so I'll move on to one more interesting thing. clustering. You have probably looked at clustering yesterday in Lavanya's talk and maybe other talks. So I will not tell you what clustering is because you already know about it. I will tell you where you see it in real life, in the context of IR and NLP. So probably have you used Google News or any other news aggregator? So typically you will see under any of these heads, you will see that articles are grouped by topics like this. So this is essentially like you are clustering articles on Indira Gandhi Airport or Air India or ICICI Bank, and if I click on any of these, you look at all the documents in this cluster, right? So this is a real life example of how clustering is useful, right, for doing things. Because another example is this. So Yippee is another search engine which is not as popular as your Google and Bing and so on, but it does one really nice thing. So if you give a query, it doesn't give you 10 blue links, it doesn't give you 10 documents. Whatever it gets, first it clusters, and then gives you clusters with some headings, and you can say, okay, there is a set of documents about a god called Krishna, about a minister called Krishna, about some Hare Krishna movement, and some university called Krishna. So now you can quickly zero in. Otherwise you have just 10 documents, and if none of them contain the Krishna University, which is very unlikely to be there in the top 10, then you have to again type more and refine your query, which you will probably know how to do, but a lot of people don't know how to do. Right? So having this helps to zero in quickly on what you want. So this is a real life example of where clustering is used for improving information retrieval. Right? So one more example where NLP is used for IR is summarization. So if you take the example of what we just saw, so we see here that they don't just give the names of documents, the titles of documents. They give some representative text from the document, right? Which tries to, which helps you decide, okay, should I read this document or not? Is this interesting for me or not? It's a very brief summary of what is the content of the document, topical content of the document. So here also you will see, typically, almost every search engine will do this. It will give snippets from the article, right, which will try to help you decide whether should I click on this link or not. Right? So you can make out some differences here. So this is like a generic summary for this article. So it's just saying, okay, this article is talking about these things. But this is a query focused summary. So here they have chosen sentences from the article which contain Krishna, because that's what I am interested in. So in the context of this query, what is the interesting thing in this document? So it is trying to summarize based on that. So typically you will find generic and query focused approaches to summarization in most, so they will state upfront what is the kind of problem they are solving. So this is an area which is not useful just in IR but has a lot of other applications. I am just talking about in this case. So another is single versus multiple document. So if we look at this, so this is trying to summarize this particular document, right? But this text here is summarizing the entire cluster of documents, right? So this is a harder problem, and it requires other kinds of methods to achieve this. So the different levels you can summarize, and each is, it's non-trivial. So also you can look at this as like a sentence or keyword based. So the different parameters, different dimensions in which you can do summarization. So for example, this is like a keyword summary of this cluster of documents, while this is a sentence summary of this document. Right? So at different levels, different dimensions, we can think of doing summarization. So typically people, what they do here is they use a theory called submodularity. That is the most recent thing which people are using. So it's all part of machine learning. So also the alternative methods are using graph theory. So there are two parallel things going on at the moment in this area. So both of them have claimed some success. So because as data increases, machine learning also improves, even if the algorithms don't. So machine learning has an edge slightly at the moment. So yeah. So another way of looking at it is also abstractive versus extractive. So what we have here is basically a selected subset of sentences from the article, right? So this is an example of an extractive summary. So more cutting edge, still open area of research is abstractive, where you try to construct the summary from scratch. This is an example of natural language generation. You're trying to frame a sentence. The way, if I give you a document and ask you to write a summary, you will probably write it in your own words, right? You will not pick some sentence from the document and write. You will say, you will understand the document and then you will write it in your own words. So that is an example of abstractive. So here we are trying to mimic how a human would like to think, right? So this is another bifurcation of approaches to summarization. So all of them use these methods that I talked about. So essentially the general, all of them have two goals in mind. They want to maximize coverage. So as much of the topic of the topical content of the document they want to cover, and minimize redundancy. So if two sentences are saying the same thing, I will use only one of them. I will not use both of them in my summary. So that is the kind of basic idea. So the whole research is on formalizing this in terms of a mathematical constraint. So for example, yesterday you saw for clustering a particular constraint was given, which you optimize and try to find out what are the best clusters, right? Similarly for classification, a method was given, an objective was given. So similarly we frame objectives and try to solve it using machine learning or graph theory. Okay. So another very relevant, which is becoming more and more relevant nowadays, is information extraction. So here we are now moving to a more granular level. Until now we are looking at document or group of documents level. Now we are looking at sentence level or paragraph level. So what we want to do here is extract entities. And what are entities? Entities are like locations, people, organizations. So there are mentions of these in any piece of text, and we would like to extract them and find relations between them. So for example, when I gave the query Lalbagh, where is Lalbagh, it gave me an address and it gave me this kind of information box, and where it says, okay, Lalbagh, this is the address, this is the phone number, these are the visiting hours, and there are some reviews which people have given about Lalbagh, some ratings are given, a map is given. So how did it get all this? This is an automatically generated thing, probably, but you can imagine this to be automatically generated. So here the challenge is this: how do I know that a number, a sequence of digits on a web page is actually a phone number, right? How do you know what is the entity corresponding to that, or that a sequence of digits is a time, a visiting time, and not a phone number or a cost, things like that, right? So this is a tough problem which is addressed in specific areas. For example, people try to build databases of products and costs. So you would have seen, if you try to buy a mobile phone or a laptop or something, when you query for it, Google or Bing already gives you some list of results from different websites, what are the costs on those websites and so on, right? So that is an example where they did information extraction to get for each. So essentially it's like you're mapping a set of documents to a database. You're automatically constructing a database from a set of documents. That is the problem of information extraction. Okay. So this is another example. This is where the initial research happened in information extraction, where because there's a lot of money in this. So you browse the web from all over the place, you get reviews and costs from. So look at this. So from 199 websites, they have identified this product and what is the cost, and they also identified reviews and so on. So this is a classic example where information extraction is used. So there is a lot of money in this because more and more people are going online to buy stuff. So this kind of analytics is really valued nowadays. So a lot of job opportunities also there. Right. So just to mention what kind of algorithmic issues and what kind of approaches are used. So essentially what we are doing is we are given sentences. So we are given a stream of tokens, right? So this is like a stream of tokens, and the problem which people try to typically attack is try to identify boundaries. Where does a named entity begin and where does it end, right? So the is not a named entity, but PowerShot is, and all the way up to HS, right? So they try to identify, okay, is this word a named entity or not, right? So then they try to categorize each word as either being part of a person or a product or a price and so on, right? So this is an example of a classification problem. I think you would have been introduced to the classification problem yesterday. So typically, currently the state of the art uses probabilistic models called CRFs, conditional random fields, for doing this kind of analysis. So yeah, if you take up a course in machine learning, you will learn more about these things. So yeah, before we proceed, are there any questions? So if you yawn wide enough, I can see it, and I can go faster or slower, or the way you want it. Okay. So yeah, so coming to any questions? Okay, so I'm going a little fast. So because there's a lot of topics, and I just want to give you an overview. So just stop me whenever you want. So yeah, because I just introduced categorization, so that is another problem which typically used. So for example, here in the news aggregator, it will give you categories for each news article. So it will group articles by category like business or India or world or technology and so on. This is at a gross level. You are trying to categorize whole documents, or as in the previous slide we showed, you can categorize single words also. So at every level, you can from a classification problem and try to solve it. Okay. So another example is this, which is more interesting, which is picking up nowadays. So for example, you want to say, okay, someone has given a review about a camera or a laptop, and I want to say, is it a good review or a bad review? Did he like it or did he not like it? Or recently it was the election season. I don't know how many of you are interested in politics, but a lot of news articles are floating around, and nowadays people can comment on those news articles. So now there are political analysts who want to see what is the pulse of the nation. They want to see, okay, what are people commenting on? Are they pro-Congress or anti-Congress, pro-BJP or anti-BJP, and these kinds of things. So for doing this analysis, you want to do sentiment analysis. You want to classify a comment or a review as positive or negative, for or against, and so on. So this is another kind of place where classification comes in. And so here is an example. So there was some camera for which Google has collected some reviews. So see, this is at a sentence level they are trying to do classification. So they found that with respect to pictures, people are saying good things about this camera, right? So now in the whole review, there is only one sentence or two sentences which are talking about pictures. So that is one classification problem. Is a particular sentence talking about pictures or not, right? And secondly, they are trying to highlight that people are saying good things about pictures. So is the sentence saying good things or bad things about the picture quality? The two levels of categorization which is happening here, because they are giving this as the rating, the aggregate rating for this. They have to give a sentence which is corresponding to that. If they say, okay, most of the people are giving 5 stars, and they say picture quality is bad, it's kind of dissonant. I mean, there's no harmony in what you are saying, right? So this is the kind of problem which you have to face, and it needs a fine-grained level of solving which you have to do. So yeah, this is another example of categorization. So yeah, MT is something, machine translation is at the core of NLP. So like the holy grail, everyone is trying to solve that most of the time. And once you solve it, yeah, you can use it for many IR things. What goes into solving MT is it's like a huge list of technologies, because it's and you realize after this research has been going on for like 4 decades now, okay, machine translation, and now you realize that, okay, when you understand what I say, the machinery that's in your brain is so complex, we don't even realize it, but this gives you an idea of how many different independent problems need to be solved in order to solve the machine learning, machine translation problem. So some of the sub-problems, for example, which we need to solve is sentence alignment. So for example, you are given a parallel corpus. You have, like, for example, parliament proceedings in different languages. So every sentence is translated in every language. So this is a corpus which is available for some European languages, and it's slowly becoming available for Indian languages also. And this is typically used for training machine learning, machine translation systems. But it's not available for most languages. So can we build such a corpus from existing data, from the web? So I have 2 corpora which are like 2 documents which are roughly on the same topic. but they are not aligned. So I want to say, okay, this sentence here and this sentence here are actually the same thing. So I can align them and build a corpus like that. So that is like one problem. And part of speech tagging, so is a word a noun or a adverb, adjective. So all these things, parsing the sentence. So this also goes back to your question answering problem. So for solving that problem also we need to do parsing, right? And sentence generation is also required because for some queries your answer is just one word or a phrase. But if your answer needs to be a full sentence, right? So then you need to have sentence generation. And you need named entity recognition also here because you can't translate names. And you want to recognize a name and say, okay, this is a name, you don't translate this and just copy it as it is, because there's no translation for a name or organizations and so on. So, language models. So language models are like a probabilistic approach to machine translation, which is the state of the art right now. There are other approaches which are grammar based, which are more rule based approaches, which were popular until the 1990s, but now they have been overtaken by machine learning based models. Right. So as I said, so the statistical or probabilistic machine translation is what is state of the art right now. And the downside is that it needs a huge amount of training data. So that's why these models are not mature in Indian languages still. I don't know if you have used Google Translate for Indian languages. Has anyone tried? It's far from perfect. You can see. Right? I don't know if it's good for Chinese, but yeah, there's no way to judge. So some of the other problems which I will not talk about, I just mention them so that you know the ambit of the whole topic. So representation of meaning. So for example, and compositionality. So compositionality is like you have a single word you can associate meaning with it, and there are usually several meanings. But when you combine two words which have independent meanings, so is the meaning of the phrase, is it is it a sum of, in some sense, is it an addition of the meanings or is it something else? For example, plum cake. So cake has a meaning, right? And when you say plum cake, the meaning of cake in the phrase plum cake is still preserved. Because it is a kind of cake, and plum is saying what kind of cake it is. But when I say piece of cake, the meaning of cake has totally changed now. So now there is no meaning actually for cake. Piece of cake has an independent meaning. So when you put, plum has a meaning of some fruit and cake has a meaning of some snack, and plum cake is a fruity snack, right? But piece of cake is not a piece of cake. It's actually something easy or trivial to do something like that. So this is like it's a tough problem in the machine translation setting. So compositionality. If you try something like this in existing machine translation systems, so for most of the time compositionality is a problem. It will try to literally translate it, and it will not sound good actually. So other thing is discourse. So for example, if I am using Google Translate, or if a 5th standard child is using Google Translate, right, the style of output should be different. The objective is to make us understand what is there in a document, right? So you have to generate something which is understandable. So there is a lot of work which has been done on the complexity of a piece of text. Is it suitable for children? Is it suitable for adults? That kind of thing. So for example, there is a parallel English Wikipedia project going on for children. I don't remember the exact name of it, but for every Wikipedia article, they're trying to construct a parallel Wikipedia article which a small school child can understand. Because if you remember your Wikipedia articles, they are fairly complex for small children to understand, right? So trying to determine, from automatically determining what is the level of a particular article or a document, how complex it is to understand. So this kind of thing, or is it casual or professional? So for example, if I am looking for some research article on some particular topic, on NLP say, right? So there is a Wikipedia article which is an introductory article, and there is some journal article which is talking about the same thing. So journal article is a more professional, precise more technologically more precise, and it's not for a layman reader, right? So depending on the audience, we have to choose a particular kind of article, a particular kind of document. So these are all aspects which which come into play, which are increasingly being used now, right? Co-reference is like I don't know if there is an example here. So basically the use of pronouns. So when you say here something like it, right? So in an article, in a document, initially you'll have a mention of a named entity or some person, and then after that it will always throw be he, she, or it, right? So now if you want to do entity extraction, information extraction, or something like that, and you want to learn the relation. So if you say that Lal Bagh is one of the big parks in Bangalore, and it is situated in Basavangudi, some place. So now it is related to Basavangudi. So what is it? Lal Bagh. So now if I am doing information extraction to find out what is the location of Lal Bagh, right, I would like to identify it as the entity Lal Bagh so that I can associate in my database Lal Bagh and Basavangudi. So for this I need to do this co-reference resolution. So this is a non-trivial problem, and there have been some approaches, but yeah, it's still being solved. And speech, as I mentioned earlier, is a whole different feature space. It's signal processing and so many other things going there, which I will not all talk about in this talk. But yeah, this also comes under NLP and needs to be solved. So just to summarize, what are some of the open problems? So in IR, personalization is one problem. So right now, anybody gives a query in Google, you get the same answer. But probably you would have seen that based on if you are logged into Google and if you have turned on your search history, it is giving slightly different answers to different people. So it's the first steps in personalization, baby steps have been taken. So this will going to go on further. And another example is, okay, in Amazon or something, if you are looking for some book or some product, you will see, okay, you might also be interested in these other articles. So this is another example of personalization. So these kinds of things are slowly picking up. The main obstacle for this is the availability of data, because this is available only in companies like Amazon or Google. So if you are working there, you can work on personalization, but not if you are working in a research setting. And if you are working there, you won't publish it also. So that is also an issue. So summarization is far from solved. What I showed you were some examples, but it's still a long way to go. And again, yeah, desktop search is also the same thing. Nobody will share his documents with other people, so that hampers research in this setting. And yeah, question answering, as I mentioned earlier. And yeah, dialogue is one of the things which is picking up now. A lot of people, for example, on websites, typically you have an FAQ section, or like if you want to find out answers to some questions. But increasingly people are using chatbots. So you've seen, like I've seen some tourist websites and so on, where once you open the website, you will get a small box at the bottom where it says, do you have any questions, talk to a person. Sometimes there's no person at the back. It's actually a chat bot. So it will try to answer automatically based on your questions. From its database it will pick and do things. So for that you need to have not just question answering, but also it should answer the Turing test. I don't know if you know what is the Turing test. Anyone who knows what is the Turing test? Yeah, and what were you saying? Precisely, yeah. So both of you are right. So is it possible to conduct a dialogue without knowing that, okay, I am talking to not a person but some machine, some algorithm, right? So that is what people are trying to aim for, because once you do this, it has got a huge economies of scale. So every site, imagine if you have someone to answer questions, it will help a lot of people. For example, I said people are not savvy with browsing on the internet and how websites are structured and all. They find it difficult to find information. But if they have someone they can ask questions to, then it really makes a difference. So, but you can't have someone sitting behind every site, because that's going to be very costly. So there are a lot of startups coming up in this space, trying to come up with dialogue systems. So yeah, this is a more recent and hot area of research. And yeah, morphology. So okay, what all I've talked about now has reached some level of maturity in English and European languages. But in Indian languages, we still have a long way to go. And one of the chief challenges for us is morphology. The thing is, in most European languages, words are atomic. So a word is used as it is. Okay, sometimes we have affixes and prefixes going on, so that even though there are two words, they actually have the same core meaning. But this problem is like heavily compounded in Indian languages. For example, in Kannada, the same word in one corpus, I found one word with 60 different suffixes. So now, without doing, okay, what is morphology first of all? Sorry. So morphology is identifying the parts of a word. What is the stem of the word? What are the prefixes? What are the suffixes? And what does each part mean? Right. So if you have work and working, so there is a stem called work, and ing is a suffix which is saying something, some modification of the core meaning. So that is called the stem is called a lemma. So this process is called lemmatization. And then you have these affixes which you try to say, okay, what is the change in the meaning we brought about by this? So solving this for Indian context in Indian language is very tough problem, still going on, because we keep adding more and more affixes to a single word, so it becomes quite complicated. So then, other than this, there is still a lot of open problems in domain specific text. So for example, if you look at Twitter, right, you can't run a normal NLP parser on Twitter text, because first of all, nobody thinks of grammar when he is tweeting something, right? And then there are so many links and hashtags and your own slangs and compressions and abbreviations and so on. So normal methods don't work as it is. So you have to have very specific approaches for doing these things. So why would anyone be interested? Because people want to mine social media and get data out of it. So that's why this is very hard. And also legal text has a long history, and it has been for a long time restricted to paper, slowly moving to the electronic realm now, and now they want to leverage it more and more and try to legal. The problem is that every document is very, very verbose, too much information. Finding the relevant information is very tough. The mic go off just now. Can you hear me? Is it back? Okay. Okay. So just yeah. So as I said again, so there are still many open problems in NLP, and for all these problems which are also solved, there are languages for which they are still open. So even these problems are not solved in many languages, which have been solved in English, for example. So so a lot of open problems, especially in the Indian context, which I hope you will find interesting. So I would encourage you to look at what's happening in the Indian context. I will give some links later, and so there's a lot of scope for work here. So if you want to read up further and try to make a dent in this space, so where would you start? So probably so what basic things that you need is, first of all, you need to be interested in language problems, because you have to be very close to the data. In machine learning in general, and especially for language, you have to be very close to the data. If you say I'll just do theoretical work, I mean, theory is one thing, and what happens in the real world is something totally different. You have to see what is there in the data, and for that you have to spend time in the data. And it only works if you like language problems. So you need to spend time there, and in order to be able to actually solve problems, you need to have some background. So these are tools which nowadays are like de facto. You have to know them in order to compete with other people who are also working in this area. So probably it already been mentioned in Lavanya's lecture and in previous lectures, and also lectures coming forward. So probability and linear algebra, optimization and algorithms, and formal languages to some extent, even though it's not so much nowadays. So where would you start finding this information? Some courses you would have already attended, and some, was there a talk already on MOOC? Okay, so you already know about these things. So these are the kinds of background that you will need to work in this. And specifically for language and IR, so these are some of the conferences You don't need to write anything down. I think the slides will be shared, so you can Google for this and see what is happening. So just see what are some recent papers like last year or this year. What are the recent work that's happening? So these are some conferences and journals. And what you might find more interesting to do, I think, is you can participate in challenges, because this is something you can immediately start doing. So data is shared. People give you training data and test data. You can write some code and compete with across the world, teams from across the world, and you'll get placed on leaderboard, and you can make some money also. They'll have good prize money. So Kaggle, I think, is one place that was mentioned. And specifically for the language area, there are all these places where they conduct yearly competitions. So it goes on throughout the year sometimes. So FIRE is especially interesting because it's an Indian language data. So recently, like, there was done data on SMS based retrieval and things like that. So it's really interesting and very relevant for current day problems. So, and you get a chance to compete and get immediate feedback also. So I would encourage you to start off with this. This will be interesting to compete with other people. So incidentally, last year, just December, we participated in one of these tracks, and IISc got first place, our machine learning lab. So I mean, it's not like anyone, just people in masters, PhD students can do. It's everyone can get in, because there's no limit to what kind of techniques we can use. So you can do your own hacks, and if you can do better than what other people are doing, then you will be respected for that. It's not just what your equations have to look like, right? So yeah, so to summarize, so I've tried to give you some picture of NLP and IR and what you would need to do to make a dent in this area. What are some of the open problems, and how do you get started? If you have any questions, I can take them now, as always.
Any questions?
Okay. Okay then, thanks once again. Okay, you have a question? I can't hear you.
For such problems, which database is the best to use?
Which database?
Yeah.
So, I mean,
categorization or other such problems, which database would you recommend?
So can you give me
the searching for words in a file?
Okay.
So which database would you recommend?
So can you give me 4 options?
I was asking you.
No, like you mean database? You mean, is it Oracle, MySQL, like that? You are asking. Okay, so I mean, current solutions don't use database at all. They write their own code. So typically you store it in files, and you have your own indexes. You can use database also. I mean, so we are decoupling the problem. Essentially, you can try all the databases which are available and see which works best. So depending on your load and where access patterns and all. So I am not an expert on databases, so I don't know if I can answer that question. But I would say it's not even dependent on that. It depends on your problem, and you just take whatever works best for your particular problem. Depends on that. Yeah.
Sir, there are many scenarios in which the availability. There are many scenarios in which the availability of data is not much. For example, if we don't have if we are having around only 3 lines per page. So how should we relate those pages to get most of the search results?
Yeah. So can you give more what is the application you're looking at?
For example, if I'm having some projects that I'm doing and I'm putting them on the web, and I want to correlate similar projects, and the abstracts is only having around 3 to 4 lines.
Yeah.
So how should I correlate them?
So yeah, this is a very specific problem. So I think this can be related to the query expansion note that I made earlier. So you have 3 to 4 lines. So what I mentioned was 3 to 4 words. So the same principle applies here also. So you can use those 3 to 4 lines and try to expand it to a larger set, right? And then, so for example, you have 3 to 4 lines. You can get a set of related documents, and from those related documents you can extract more words which are representative of that set, and then form a larger query of maybe 50 words or 100 words, and then again query once again. So that is one classic approach that's used.
And what would be the feasibility of such approach should we at what point should we stop the optimization for such processes?
So this is we are entering the black art part of machine learning and IR. So this is usually there is no one good answer for this. It will depend on your specific application, the algorithm used, the parameters, the thresholding that you have. So it will depend on a lot of things. So there are some attempts which go into formalizing this, but more or less it depends on your application. So there is really no one good answer for this.
Thanks.
It's a good question, but yeah.
Thanks.
You mentioned there are rule-based approaches and machine learning approaches happening now. Are there still rule-based approaches in Indian languages, or are we shifting to machine learning? I mean, is it always appropriate to use machine learning to Indian languages?
So, no, I mean, for example, to answer the first part of your question, so the first natural language system that was built for Indian languages was a rule-based system. I think it was built by CDAC or one of those institutions, and it was like somewhat based on the Paninian system of grammar, because that is the root for most of the Indian languages, almost all the major Indian languages. So in that sense they did something, but when you go to the website and try it out, they have a place where you can try it out. You'll see A, it's very slow, and B, it doesn't handle all cases. The thing with rule based is it is very accurate, but it can work over only some specific subset of things. So I'm not saying that rule based should not be used. It is used in conjunction with probabilistic models, because uncertainty is handled better by probabilistic models. So you have to use a conjunction of both. Even in the state-of-the-art system that Google Translate or whatever you talk about, they will use rule-based approaches. It is an integral part, but it is put in a probabilistic framework. So that will be one aspect, and there will be so many other things. So yeah, definitely rule-based is there, because if I know something should work like this, instead of leaving it to chance, I would rather hardcode it into the system. There is no point in leaving that for chance. Right? So typically they will have a probabilistic model with hooks where you can introduce rules. Right? For things that you know for sure. That's how people usually do it. So yeah, it's a combination of both, hybrid. Usually all real world systems are hybrid as far as I know. Okay, I think I'm out of time now. So I'll be in machine learning lab, so after a break or anywhere, if you want, you can come and talk to me. Okay? Okay, thank you.